the last class we have learned about amino acids, alpha amino acids. In this class we will learn about the synthesis of amino acids using Gabriel phthalate synthesis and streaker synthesis. Amino acids, they are called as alpha amino acids because CH2, NH2, COOH, right? So functional group is acid and this is alpha carbon. In the alpha position we have an amino group, right? So they are called as alpha amino acid, right? We already know the classification of amino acids, that is neutral, acidic and basic amino acids depending upon their structure. Neutral amino acids, example this one, this is alanine, right? Alanine amino acid, glycine, not alanine, glycine, CH2. If there is one of the hydrogen is replaced by methyl group, it is alanine amino acid, right? Now we will learn the synthesis of amino acid. First one is Gabriel phthalate synthesis. Gabriel phthalate synthesis of amino acids. It is synthesized from potassium phthalamide. Potassium phthalamide on treatment with chloro-substituted ester, say Cl, CH2, C double bond O, ET. The name of this compound or molecule is chloroethyl acetate, right? Chloroethyl is acetate. So now what happens is this nucleophilic nitrogen atom attacks this CH2 group. This chlorine leaves as a chloride anion, combines with this potassium chloride is getting eliminated. So we are making a nitrogen carbon bond. So now we will have a C double bond O, nitrogen bonded to this carbon atom, CH2, COO, ET, right? For this on hydrolysis. It undergoes hydrolysis. Or when we hydrolyze this molecule, what happens is we break this bond, this one, and over here, right? So what happens? It will result in formation of NH2, CH2, COOH. This one will get eliminated as ETOH, right? And this will form the dicarboxylic acid. COOH, COO, and the remaining this will become NH2, CH2, COO. So we have obtained an amino acid. This is glycine amino acid, right? So depending upon the product that is required, depending upon the product or amino acid that is required, we can alter the ester. The chloro or halogen substituted ester can be altered so that we can synthesize the desired product. The desired amino acid can be synthesized. This is Gabriel phthalate synthesis. Gabriel phthalate synthesis of amino acids. Synthesis of amino acid using streaker method. Right? Here what happens is, or how it is synthesized in streaker synthesis. Aldehyde is treated with hydrogen cyanide and ammonium. That is first it is treated with ammonia, then hydrogen cyanide. The resulting compound is hydrolyzed to form a product is formed, and this product is hydrolyzed, right? Hydrolyzed, and it will result in formation of corresponding amino acid depending upon the aldehyde that we are using. Right? If you use acetaldehyde, it will result in formation of glycine alanine amino acid. Right? So depending upon the aldehyde, the amino acid differs. So CH3, C double bond O, H, right? An aldehyde. First it is treated with ammonia, NH3. With ammonia, what will happen? It will undergo condensation reaction. NH3, H2O. Remove H2 from ammonia and oxygen from aldehyde. So remove H2O. Dehydration. Right? We know the mechanism that the lone pair of electron attacks the electrophilic sp2 iodized carbon atom. Shift off this bond. Right? So this will become OH. Then eliminate one of the hydrogens in NH3 as H plus ion. Then make a double bond between carbon and oxygen. So what is the product obtained? In the next step is CH3, single bond, C, double bond, NH, single bond, H. Right? So this is the product obtained. And imine, right? Carbon, nitrogen, double bond. Right? This is treated with hydrogen cyanide, HCN. Hydrogen cyanide. HCN, so it will dissociate to produce H plus ion and Cn minus ion. The Cn minus attacks carbon atom. So shift the pi electron over nitrogen atom. So what will happen is we will have CH3 single bond C Cn single bond NH minus. This NH minus will get protonated and it will get converted into NH2. Protonation abstracts H plus ion. So CH3 single bond C triple bond N single bond H single bond NH2. This on hydrolysis, right? This on hydrolysis, what will happen is this bond will undergo cleavage, carbon nitrogen bond, triple bond will undergo cleavage. This will get converted into COOH. CH3, single bond, C, NH2, hydrogen, COOH. Right? This is alanine. Alanine amino acid is synthesized or obtained when we use acetaldehyde as the substrate. Acetaldehyde reacts with ammonia and hydrogen cyanide to form the corresponding alanine amino acid. Right? This is a streaker synthesis. Streaker synthesis of amino acids. Next step, isoelectric point. Isoelectric point, right? We know that the amino acid is zwitterionic in nature. CH2, COO minus carboxylate anion, and we have NH3 plus. So it is both, it contains both charges, plus and minus, right? Acidic as well as basic in nature, right? So in presence of or in alkaline pH, in basic pH or in alkaline pH, what will happen is this ammonium NH3 plus will lose one of its proton and it will get converted into NH2 single bond CH2 COO minus, say 1, structure 1, right? In acidic pH, what will happen? This COO minus will get protonated and it will form carboxylic acid NH3 plus, it will remain as it is. CH2 COO minus will get protonated, it will change into COOH. This is, say, structure 2, and this zwitterionic form is 3. Right? So consider we have this 1 and 2 molecules represented as 1 and 2 are present in a beaker, right, in an electrolytic solution, right, in which we have introduced the electrodes, cathode and anode. Cathode is where reduction happens, anode is where oxidation happens, right. When we pass current or when the electric field is applied, what will happen? This positively charged cationic molecule will move towards negatively charged cathode, right? Will move towards cathode, and this negatively charged anionic molecule will move towards positively charged anode, right? Positively charged anode. There is component. Positively charged cationic molecule will move towards cathode, and the anionic molecule will move towards anode. In presence of electric field, right? But what happens is at a particular pH, right? It happens at every pH. At a particular pH, what will happen is this movement of the charged species, cationic species as well as anionic species will stop. That is, there will be no movement of cation and anion move towards the cathode and anode. So that pH, a pH at which there is no movement of the amino acids is known as isoelectric point, right? At that point, what happens? The migration of anion and cation towards the cathode and anode is stopped, right? So there will be equal amount of cation and anion, and there will be no movement or no migration of cation and anion towards the cathode and anode, towards the electrode. So that particular pH is known as isoelectric point. Isoelectric point, right? So isoelectric point is the pH of a particular amino acid at which there is no migration of the cationic and anionic amino acid species, right? So that is isoelectric point. So this isoelectric point, it differs for every or each amino acid. Each amino acid has its own isoelectric point. Say for example, alanine, glycine. Alanine has an isoelectric point. It means what? Its isoelectric point is at a specific pH. When the pH changes, there will be again migration of the ions towards the electrode. Similarly, leucine, isoleucine, alanine, glycine, each amino acids, they have their own isoelectric point. Thank you. We will learn about the next chapter or next topic in the next video. Thank you.